Hello, it's James from XRobots.co.uk. This is part 33 of Ultron, the Real Robot. In the last couple of episodes, we've been dealing with motion capture, and I made a little puppet I can move around, and Ultron mirrors the motions, apart from one arm which interprets the rest of the body language as if I'm driving a prosthetic arm. And the aim was to wear the motion capture suit, but it's actually much easier to put on the little maquette. So before that, we were messing around with some sort of sensing and Ultron's brain, vision and things like that, and we're actually going to return to sensing in this episode and deal with hearing. I'm also going to have a look again at the vision. We've got a pixie cam there that does blob tracking quite well. The eventual aim will be to actually redesign Ultron's head, which some people will be happy about, to build the camera into the eye and build microphones into his ears here. But first of all, we need to work out the sensing, try and get that nailed down, and then decide how that fits into the head. Right, so to do audio processing, I'm going to use a pair of these, and this is the MSG EQ7 Breakout from Wizoo. And so you can get this chip on other boards from various other places, including SparkFun and so on. But basically, this is a chip that does a 7-band graphic equalizer, so it'll pull out the intensity to those frequencies, and it's got an audio socket in, and it connects to one analog pin of an Arduino, and gives you all of that data. So we're going to use a pair of these, one for left and one for right. So I set those up there and connected them to an Arduino, and even though I don't have a stereo version, I've got two of course, and I've connected them both to an Arduino, and I found a library here, Nico Hood, the MSG EQ7 Arduino library. So it's got some good documentation, tells you all about it. There's a wiring diagram and a hookup diagram here for basically building it on breadboard if you had the bare chips. It mentions a ready-made board here, but essentially it's just two chips on one board. So I've just basically connected the same pins up here to my Arduino, and everything's good, and it explains what to do here. There's a lot of usage for the API, and there's an Arduino sketch which I've got loaded here. I'm not going to go through it in too much detail, we'll just look at the output, but basically this is separating the bass from the left and right, and also giving us some visual representation of what the audio is doing. So I've now got one microphone plugged into one channel here, and I'm looking at the data that's coming out of this Arduino sketch in the serial terminal, and this is just pulling out overall volume, and it's also pulling out the left and right intensity. I think it's pulling out the bass frequencies looking at the code, but we can pull out 7 different frequencies. So now if I go and hit the mic, yeah, we get this visual representation on the right hand side of the overall volume, and you can see the numbers for the right channel changing because I'm only plugged into one channel there. So, and the numbers on the left I think are overall intensity. So that's not much use to us. It's really hard to see what's going on, but if we use the serial plotter we get a nice little graph. So hopefully we can see some frequencies getting pulled out more than others, and that seems to be working. So short of doing some further analysis, that's pretty good. So the problem is this mic is a mic level coming out, and the breakout board is expecting a line level, so we need to get a couple of mics and some sort of mixer or preamp, and then we can carry on with the experimentation. Alright, so I've now set up this massive mixer, which is from my home recording days. It's a bit overkill really. All I need is 2 tiny amps, which I can build out of a couple of tiny chips or one chip on a board. But it'll do for testing now, and you can probably see these red lights flashing as I'm speaking. So now we've got proper level coming in off these. We've got a preamp, and we're going in line level into the 2 breakout boards. So you can probably see on the terminal as I'm speaking, the data is it's giving me data there. So I've got left and right separation. So this is left. So you can see the left number's getting bigger, and obviously that's the right channel. So I've actually isolated the data here, so I'm just looking at the 2 channels. And we're looking at the bass frequencies, but it doesn't really matter. Obviously this is the plot now, so you can kind of see me speaking and so on, and again, that's the yellow line, and that's the blue line. But as per the documentation, we can pull out different frequencies, so we can either get the actual frequency, or we can pull out the bass, the mid, and I believe there's several documented here that are predefined. So yeah, bass, low, mid, high, which is probably actually enough for our purposes. So in fact there's 7 frequency bands I can pull out, so there we go. So we can have identification of different sounds, and we can do some experimentation with that. Right, so I thought I'd build a tone generator, and I've just used an Arduino Pro Mini here, a little 3 watt amp I think it is, and a a bit of a knackered old speaker, unfortunately. It's got a USB power bank on the back, so I can wave this around making different tones, and if we turn it on, the speaker's a bit knackered, so it's a bit crispy sounding at certain frequencies, but anyway, you get the idea, and obviously it's got a switch so we can power it off because it's going to be really annoying. And the code for that's really easy. I'm just using the tone function in Arduino, so you output the pin number and the frequency, and that's coming from the analog read, which I've multiplied by 2 to go up to 2 kilohertz, because the maximum number you'll get out of here is 1023, so that seems to work pretty well. Right, so now we're just pulling out the code there for the different frequencies. So I've got the 7 channels there, 0 through 6 defined, and I've got my tone generator. So now we have a look at the serial plotter. We should be able to see that if we turn this on, it does actually, obviously me speaking is doing something. If I'm silent, it drops to nothing, but there we go. So it does actually max out some of the channels. But we can see as we turn the knob, we can see how those different frequencies respond. So we can do this in both channels, so we can get stereo separation, and we can also work out which frequencies, or pick out a specific frequency to listen to. Of course, what we want to do is put some microphones either side of Ultron's head or somewhere. We might have to put them wider. I haven't really decided yet. Maybe they go in the shoulders. We need to filter out the motor noise of Ultron's head turning, and then we want to feed that data back to Ultron's brain so it can decide where to look based on the sounds. We also need to integrate the vision, and once I've decided exactly how it hangs together, we can redesign the head, hopefully, to fit all those things in. We've currently got an Arduino taking all that data plus the touch sensing data, but we really need to look at that and tidy things up before we can continue. So we have Arduinos in the body that control the motors, but we have one that's controlling sensing, or at least reading all the sensor data, and at the moment that's hung on its own wires hanging out of the back here. The intention was to build this into a nice box and everything, so we've got all of the sensors coming back from the series elastic actuators, or the full sensitive resistors in the joints. That grey cable there is the data from the Pixie Cam, and we've got some more unpopulated connectors here we can shove our stereo audio into. And that can go in there as well, and that's sent back over Bluetooth back to Ultron's brain. If you missed the few episodes before we started doing motion capture, this is Ultron's brain. It's got 2 Arduinos, lots of LEDs in it, and some things that move on top, and lots of exciting stuff, and a bits of control panel for various things hanging off. Look back for the previous episodes. This takes all the data from Bluetooth, from the sensing. It's got a speech synth in that's sent back over Bluetooth audio to the robot, and it sends data back to make Ultron move. So we've got quite a lot of data now. We've got, in each joint, there's 2 force sensitive resistors. Each of those are analog, and altogether there's 12 of those. At the moment, I'm stripping that data down in that Arduino and sort of sending a 1 or a 1 the other way if the joint is getting pushed. But I really like to get the analog data back to the brain. The camera has X and Y coordinates. At the moment it's only programmed to track one object of one colour, but we can track up to 7 different colours with markers. So we need to send that position data plus which object it is. And now we've also got the hearing, so not just stereo channels, but we've actually got 7 frequency bands in each channel. I'd like to send that data back. So at the moment it's pretty inefficient. I'm just sending the data back delimited by commas, and then doing a parse int on the Arduino at the other end to turn that string representing the character back into an actual variable. And it's okay when I'm mashing the data at Ultron's end, but if I want all that raw data back, then I need to do something else about my communications protocol. Just to explain that a little bit more, the data looks like data, literally comma, then some data, comma, then some more data, comma, data, comma, data, comma, data, comma, data, comma, and it sends all that in one massive sort of string. And we can only have 64 bytes in the buffer of the Arduino, so each piece of data, if it's an integer, is typically 2 bytes, the comma takes up another byte. So quickly we can exceed the buffer length. And of course if there's a cut in the wire or the Bluetooth or something goes wrong and we end up cutting off and missing a bit, then the receiving Arduino doesn't know any difference, so it just picks up where it left off and then the data goes in the wrong places and Ultron does a funny thing and it's not great at all. So what we really need is some proper flow control, some way of checking the length of the data, checking it's all there and throwing it away if it's not. Fortunately, all that hard work's been done for us though, and there's an Arduino library called Easy Transfer by Bill Porter, and basically there's a serial UART version and I2C version. There's some good documentation, and basically that just zips up all your data into a structure and sends it over and checks it at the other end, and if it's rubbish it throws it away. So if we delve in, there's some examples here, but if we look at the actual library, we can see the piece about getting that structure there is sending it with a header, sending it in binary, so it's making it much more efficient than sending strings and parsing them back into integers or whatever. Sends the length info and a checksum, and this is the receiving part, which is quite a lot of code, but the most important part here is if it fails the checksum, then it throws it away and starts again fresh. So I've butchered the examples to some extent. So this is the transmitter here. So you basically import the library there, set up your data structure, and you have to set this up the same at both ends. I've called it my data. In fact, that was what was in the example. I've opened the serial port at 57600 board. That's the serial port I'm using. I'm sending from an Uno, which only has one serial port, which is serial 0, but if you had a Mega with more ports, you can have more. And then all you do is you name your group and your variable name. So I've got my data, data 1, data 2, data 3 and data 4. And data 1 is 100, the other two are 200, and data 4 is counting up. So every time the cycle goes round it gets one bigger. And all you do is ET send data. And I've got a delay there of 100 milliseconds. Now on the receiving end it's a very similar story, so we've got the same variables and everything there. I've got two COM ports specified here. The one I'm receiving from is serial 1 on the Arduino Mega. It's got 4 serial ports, and that's because I'm keeping this one free to look on the console. And the rest is very similar. We've specified serial 1 there for the actual library to use, and then we do ET receive data, and then the variables just appear. So now I can print those out to the console, and as you might imagine that's already running. So let's just open the serial monitor and we should be able to see those numbers appearing. Now the Uno that's transmitting has been running for some time. In fact, if I reset it, you should start again at the beginning. Yeah, 1, 2, 3, 4, 5. And the other variables are of course the same, and I'm receiving onto the RX1 pin of the Arduino Mega here, and you can see the data happily flashing away. And even if I mash those wires and cut the data off, it never goes wrong. If it gets half a piece of data, then it just chucks it away. So you can see every time I'm plugging it in there, we're getting a bit of data, and if I unplug it, nothing. Now I don't know where it goes. There it is. I'm back in again, and whatever you do, it never corrupts the data, and we can send as much data as we want, up to 255 bytes, which is amazing, and there's no commas or anything taking up space, so that's more than enough space to send all of those variables back from all of Ultron's bits and pieces. The last thing I can do before I chuck all my data over the line is sort out the vision. So if you saw my video on Friday about VR tracking, then I'm going to make a very similar thing to that, which is this light box with a diffused screen, and we're going to put 2 coloured lights in. I've also got some switches so we can change around the lights, and we can use that so Ultron can see it as different objects, and we can get maybe 3 objects tracked and send that data back over. So basically it's an ABS box with a nylon screen. We'll put some NeoPixels in, and that should make it much easier for Ultron to track in varying lighting conditions. So I thought I'd have a go at printing the screen on its edge. Again, this is Toolman Alloy 910, and it's really translucent. It's a millimetre thick. It's about maybe 25% of the way up, so we'll see how that goes as it gets all the way to the top. Here's the base of the box. It's going to take a while, a few hours, probably 3 hours. It's about 4mm thick, and I'm just printing it in white ABS, so the lights reflect around and are diffused inside. So that piece of nylon failed. Obviously the nylon is very warpy, so you can see it's bent as it's gone up, and then the filament hasn't printed on top anymore, so I hardly ever have failed prints, but there we go. I should keep that one in a glass case. So I printed one flat, and that was all fine. So here's my box I've made. The diffuser fits nicely in there, and I've already fitted the electronics. So we've got some NeoPixel strips and an Arduino Pro Mini, and we've got the power switch there, so that illuminates. We've got yellow and blue there, and various different combinations of colours that we can have, so we can have 4 different combinations. Alright, so I've just turned Ultron's head round, so I helpfully put this connector on. That means that I can take it off easily. So I've just plugged the Pixie Cam into the PC so I can reconfigure it for these labels. So I've already allocated the coloured labels for the colours. So if we turn this back on, you'll see it's black at the moment, but basically I've turned the brightness right down, even more than I did for the VR project that came out on Friday. Have a look at that. So it's practically black and it's pretty well lit in here. I've got a big photography light up there pointing straight at me. But even that weak yellow, we can still see that pretty well in Ultron's field of view. So if I change the colours, of course, the label changes. So we can now see that's 23. And we've got numbers there, so it's just identifying the two labels. 1, 2, 3 and 4 basically in their different order. And if I turn this upside down, 1, 2, what do we get? No, we still get 1, 2, so that's good. So it works in any orientation as well. And it tracks all the way around, all the way, pretty much back to here, which is probably 6-7 feet from Ultron, which is fine for waving something in front of his face and having him track it. So now he can track this as 4 different objects. And we can send that data over to the brain, and basically it can respond differently to it. Right, so I've just gone back to the default Pixie code, which I've installed on the Arduino, and I've got the camera back in Ultron's head. So now if I turn on my little light box, we should be able to find that it starts detecting things. So you can see there we've got block 0, because it's the only object, detected 1, and the signature's 14. And if I change the switches, the signature there's 24, which is just the 1, 2, 3 and 4 colour-coded objects in order. So 23, 14, which one have I missed? 23, 12, and 24, and of course it gives me the angle and it gives me the dimensions in the field of view there, so now we can report what the object is and where it is. So back to the Arduino hanging out the back of Ultron. So I've now got my MSG Q7s on this bit of board here with the stereo audio coming in, and that's wired into that Arduino, as well as the Pixie cam, which is on this lead, and as well as all the force-sensitive resistors in the joints. So now this is my sensor Arduino that'll send all the data off. I've swapped those big mics for some little tie-clip mics, and I've put one on each of his ears here. So I don't know if I'll use these mics, but they'll do for now for testing. The mics have got their own little thing that powers the microphone with phantom power with a battery in, but they still don't have any preamp for line level, so they're still plugged into this mixer. That won't be the case forever. I'll build a little preamp that fits really in them, that's made of one chip probably. But for now we need this mixer to boost the line level to go into the MSG Q7s. So now we've got Ultron's hearing working, and you can see the effect we get there from the Arduino. So I'm just looking at the audio data for now. If I stroke this one, you should see the top peak is blue, and there the top peak is red because we've got left and right channel separation and all 7 bands. Right, so I'm now simultaneously running the sound and running the vision, so you can see if we look at the screen there, if I make some sounds, you should be able to see the numbers jumping, and if I wave this in front of Ultron, we should be able to see the left-hand column is the coordinates there, plus minus in the second column, plus minus in the first column, and the ID is now a binary representation of the colour code, which is actually an octal number. So some reading to do on the Pixie manual, but nonetheless I've got different IDs, so I can identify the object and we can do sound as well. It's a bit easier to see on the serial plotter perhaps, so if I now wave this, we can see the coordinates as well as the sound transposed on each other. So yellow line is up and down, of course, and the blue line is left and right. And obviously sound is the other thing, so as I make some spikes we see them, so we've got all of that data. We now need to zip up the force sensitive resistor data that we've also got in Ultron's joints and bring that in and send that whole data structure off to the brain using the Easy Send library. Okay, so it's called Easy Transfer, but anyway, Ultron is now at the other end of the room, and all the data is being sent over to his brain where all the programming happens. And that data structure looks like this. So we've got the block X and block Y, which is the camera tracking plus the signature for the item it's tracking. We've got all of our frequency bands, all 6 of them or 7 of them for left and right, and we've got 12 force sensitive resistors, which are the force feedback resistors basically. So I've started rewriting this code for the reflex and reaction Arduino in the brain, and I've just started again with the vision stuff. So basically this is sort of the vision here, which just moves the head a little bit as the block moves, and I'm also tracking hearing by looking at one of the frequency bands, and that one's band 4 at the moment, and basically doing some mapping and moving the head when it hears things, and the stereo hearing works quite well. So let's see what that's like. Right, so let's have a look at vision first. Hearing is working at the same time, which is why Ultron is moving his head, because I'm moving around and talking. But if I turn on the light box here, we can see that works pretty reliably now. His head should go purple. So you should look up at that, down and all around. It only turns red again when the vision tracking returns 0, which is when there's nothing, or when it thinks it's perfectly on target. So pretty good with that. It works for some distance away as well. And obviously as I change the colours, it still tracks it for now, but it will report a different colour code. Alright, so let's have a look at hearing. So now, you can see its head turning yellow if it hears a sound loud enough. And I chose this frequency band because it basically filters out the sound of the motors. So the louder the sound, the further it turns proportionally from left to right. Hey! Hey! And that works pretty well. It's pretty good to just about move in the right place. Ultron! Robots! Hey! 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 Obviously, if you shout too loud, it'll turn too far. But there we go. It shouldn't really. It's taking the difference between the two mics. Not sure if I've got good enough stereo separation. Maybe they need to go further apart. There's obviously reverb in the room as well, which doesn't help. If I go really close, it's good. Ultron. Ultron. Robots. 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 You're a robot. So, seems to work pretty well, at least good enough to carry on developing with. And the great thing, of course, is that I can get all those frequency bands in the brain and pick and choose, or I can make a sound generator that generates 2 frequency bands and it only listens to that, and then it will know what the ID is, so it can pick out specific sounds. Robots. So now I have all that data in the brain, including the full sensitive resistors in the joints, that actual raw data, that opens up quite a lot more possibilities for processing and doing some programming and integrating with the emotions. Check out the previous episodes for that. Next time, I think I'm going to redesign the head to build these microphones, or some microphones in, and also probably it needs modifying anyway because there's some bits missing and it's a bit skinny in the jaw. So I'll either do a heavy modification or a complete redesign, and we also want to put this camera somewhere sensible as well, get rid of the eyebrows and all those good things. So don't forget to subscribe for more updates on this project and other projects. You can also check out my Patreon campaign, which is how most of these projects are funded. Have a look at patreon.com/XRobots, where you can get access to some exclusive rewards, including a live broadcast with me and access to all my videos early. I also have a t-shirt store with an exclusive t-shirt design which expires at the end of March 2017, and hopefully there'll be another one after that if you're watching in the future. So check out those links in the description as well. Alright, that's all for now.